All right, so welcome everybody to this class. This is another wonderful session, and I'm so glad to see you all here making progress in this course. This is data visualization with Power BI, and in this course, we are learning to become professionals. We are learning to become data analysts with Power BI skills. And so far in this course, we've made a lot of progress. We've covered two major reports talking about business and retail and healthcare. And we have understood a lot of concepts in Power BI. And in this particular lesson, we are taking our knowledge to a whole new level. All right. So I want you to be ready to learn new things about Power BI and new things about data visualization, because what we have learned previously is just a foundation. Even though it is so rich and very, very deep, today we are going to talk more about real world data visualization. We are going to talk more about complex data visualizations and how to create a model for your visualization. A short quote that I have for you today is that ignore the noise and focus on your work. Ignore the noise and focus on your work. There's always a lot of distractions, a lot of noise, a lot of disturbances and challenges that will try and distract you. But focus, pay attention, focus on what you are doing. Focus on it and you will succeed. Someone said the meaning of focus is follow one course until successful. That is what FOCUS stand for. Follow one course until successful. And so that is why we are zooming in on Power BI, and the journey has been incredible. Over the last 2 or 3 weeks, we have achieved a whole lot, and we are taking our knowledge to the next level. This course is titled Microsoft Certified Power BI Data Analyst Associate Certification, and we are taking the self-study on the Microsoft platform, as well as having real life classes. And we've covered our practical introduction to Power BI. If you missed it, check the videos and you will learn everything you need to know. I believe these classes have gone so well, and everyone who has followed the course has really understood it. This is a professional course. This is a certification course. After this course, you will acquire the practical skills and you will be certified by Microsoft. Great Africa will also issue a certificate of completion and will celebrate everyone who completes this course. We've had our guided demo. Most of you have presented your works, and we have covered the details of data loading from multiple sources and data transformation. Today's lesson is on something very powerful, and it's titled data modeling. If you can hear me, please type that in the chat for me. It's called data modeling. Data modeling. Now, this concept of data modeling is so wonderful, and it will take you to another level. What we have achieved already is amazing. You can work with it. You can build reports for a lot of organizations. But where we have gotten to, we are going to be more technical, and we are going to move to the advanced areas. So after we talk about data modeling, we will start working with multiple tables in our data. What I mean is that when we are creating reports, instead of working with a single table, we are going to be working with multiple tables and multiple files from multiple sources. And that is how real world data looks like. And because of that, you need to get into proper data modeling before your data will be complete for analysis. So let's get ready to move to a whole new level. This is exactly what we built in our previous lesson. And this right here, I think is fantastic. It's amazing. If you can build this, this is incredible. So we've already achieved this. Every one of you has done this. And this is very interactive and displays real KPIs and displays real data about the health center. And we have built this for a retail business as well. And today we are moving to another level where we will be working with multiple data sets. All right, so this lesson is titled Data Modeling. Thank you for typing it. And the subtitle is Design Relationships and Build Meaningful Models in Your Data for Accurate Analysis and Scalable Reporting. So what we are going to do is to understand the concept of data modeling. And once we do, we would have covered one major gap of knowledge that we need to be really professionals at building reports and dashboards for all kinds of businesses across multiple industries. And so we will focus on what modeling means, and we will focus on building relationships. And we will spend some time thinking about why we need to build data models and why relationships matter. Why relationships matter. So we'll do that. And by the end of this lesson, you will confidently design relationships between tables, build a structured data model, and organize your data to support accurate analysis and scalable reporting in Power BI. I like this lesson so much, and I think this is actually the most important lesson in the entire course. It's the most important lesson in the entire course. So, what is data modeling and why is it so important? This is the first thing we need to understand. And once we do, our knowledge of Power BI will really expand. So what is it? Now, data modeling in Power BI is a process of connecting tables and organizing your data into a meaningful structure. All right. So let's break this down because this is one area that we are yet to really explore. And like I said, this is where we feel a major gap in our professional learning journey. And once we cover this gap, then we have really done it. I think this is really the backbone of Power BI. And if we can really get this done, understand this, add this to our knowledge, then we will be really ready. Next will be about polishing our DAX skills, and that's all. I think we've done most of the work already. All right. So data modeling is the process of connecting tables. Please type connecting tables in the chat for me. Connecting tables in the chat for me. This is very, very important. Connecting tables. So this is important. We need to understand that in the real world, the data you will be using to build these visualizations, they are not in one table. All right? We need to understand that first. In the real world, things are usually very busy and very messy. And although we have learned how to transform our data and make it clean, we need to understand that there are multiple tables across businesses and a business. There are multiple data sets that need to come together before the report can be built. In the real world, you will not usually work with a single table. And so in one of my slides, you are going to see that working with a single table is easy. It's very easy when you are building a report from a single table. But when you are building a report from multiple tables, you have to actually know how to connect the tables. You need to understand the tables and the kind of data that exists in the table and have the knowledge of how to connect the tables properly so that the tables can communicate with one another to provide the right insights and to provide the right metrics on the report. In a single table, all the columns and the rows exist in one place. And so, for example, with what I showed you here, when you click on this, you can see that all the metrics here will respond to that. I believe you understand clearly. When you go to any of these slices and you select any of them, I'm not selecting because this is a still image, all the data and the numbers and the metrics will all respond to that. True? Let me know if you understand that part. All right, so Robley says yes. Robley is always fast. All right. Now, when you are working with multiple tables, if the tables, listen to me, if the tables do not have any relationships, what that means is that this part of the reports may be coming from one table, this part may be coming from a different table, these cards here may be coming from a different table, and so if the tables do not have a relationship, if you click here, if you click on this will not move, that will not move. If you click on the slices, nothing will move because they don't have any connection. And so in the real world, before you can build a proper report and proceed to build a dashboard, you need to do the work of connecting the tables meaningfully with understanding, because Power BI will try to automatically connect the tables and establish the relationships for you, but Power BI does not understand the company and the data as well as you, the analyst, and so you have to do the job of connecting all the tables so that they can communicate and have that relationship. This will properly organize the data into a meaningful structure, and this is called data modeling. As a matter of fact, when working on a serious project, if the data modeling is not done right and well, the report will not work. Over here, I have a picture of multiple tables before modeling and after modeling. After the data model, you can see clearly that relationships have been established. So in this particular lesson, our job is to understand the importance of data modeling and what it is, and also understand a lot of terminologies under data modeling, expand our knowledge to cover real-world projects, and work on a live project consisting of multiple tables and building the real data models and understanding them practically. This structure makes it easy to perform accurate, and I like the term scalable, and then powerful data analysis. When data models exist, you can now build reports for large organizations and enterprises because the model makes the whole project scalable and the whole reporting scalable for you to expand the scope of the reporting and eventually the dashboards you want to build. Especially when your data is spread across multiple tables, multiple files, and multiple data sources. This means that in real-world projects, your data will not come from a single table, but will be spread across multiple tables. Sometimes you will do the work of bringing all the data sets together, understanding what data sets you will need for your projects, understanding how to establish the relationships, how to create the right connections. You have to know the connections you will need, the connections you will create that will make the entire data set across all the tables, and all the tables become a single model where there is a strong relationship and there is communication across all the tables. And so if you request information from table A, others table, it talks to products table to retrieve the information, and you can connect to multiple tables and build a very scalable report. All right. I don't know if anybody is following what I'm talking about and anybody is understanding. If you are following, let me know in the chat that you are following. Robley says I'm following, and Benedine says, yes, I am following. So this is why I said, let's be ready to expand our knowledge, because before today, we had achieved a whole lot, and the reports we built were amazing. Very soon we'll build dashboards. However, there are some areas that we have not got into, and this is where we are now. In the real world, data is usually spread across multiple tables, multiple files, and data sources. Working with a single table is easy, but when you are working with multiple tables, relationships must be created. I want someone to type that for me. Relationships must be created. Relationships must be created. So this is important, and this is not something you can choose to do or something you can decide not to do. This is really important. Now, if you are working with a single table, it is one model already. It is one table already. So all the columns know one another. They know themselves. But when you have multiple tables, this time different entities, the tables are also referred to as entities. Different entities must now talk to one another. One table is one entity. All the columns know themselves. And so this is why everything works so easily. But when there are multiple tables, you need to make sure the relationships are done right to connect the data. So just like I showed you, this is just a quick example to let you know. Later, we'll get into Power BI and we will see how the relationships really work, and we'll understand all the technicalities of establishing this relationship. Now, without relationships, your data cannot communicate, your slices will not work, your analysis will be incorrect, will be incomplete, and will be confusing. So someone will ask, is data modeling important? What do you think? Tell me in the chat. Do you think data modeling is important? Do you think it is important? Anybody? So someone says yes, someone says very important. This is really, really important. And this is where you really want to understand about Power BI, because where we've gotten to now, if you can grasp this, then you have really made it. You've really made it. So this is the part we are getting to, and we need to be ready for some new information. Now, data modeling brings everything together for unified, meaningful analysis. So in short, data modeling is a process of defining how different tables relate to one another so that you can analyze your data accurately and efficiently. It is a process of connecting tables and organizing your data into a unified, accurate, and scalable structure for analysis. After you build your data model, then you are really ready to create your report for insightful analysis. Most Power BI projects benefit from data modeling, especially when dealing with multiple tables or complex data sets. So we have seen the workflow of a Power BI project. We've seen how to get data. We have seen how to transform data and to build visuals, save and share. But I have a question for you. Where does data modeling fit in the Power BI workflow? Where does data modeling fit in the Power BI workflow? So who can tell me? Because if you've been following the course, you've seen that we have the get data step, then we have the transform data step, then we have the build and format visualization step, and the publishing step. Yes, so we understand that this workflow is so important. We've talked a lot about them. At this time, we are introducing something that right now we all understand that is very important. But where does it fit in this workflow? Where does it fit in this workflow? So I can see a lot of responses, and I think you are right. I think you are thinking right. And so let me give you the answer now. And the answer is that data modeling is an integral part of the transform data step in the Power BI workflow, even if it's not always shown as a separate step. So when it comes to transforming data, this is where we ensure that our data is ready before we get into the building of the visualizations of the reports. And to get your data ready, apart from cleaning individual tables, you need to ensure that all other tables are clean. When working with multiple multiple tables, it is very important. Now, when we started, we've been working with single tables, and so you don't usually think about multiple tables. But when there are multiple tables, you need to ensure that each table is also clean. So you go to the tables one at a time, make sure they are clean, and make sure they are connected, clean and connected. If you are working with a single table, after cleaning it, they are connected already. But most of your complex projects, your real projects, are going to be from multiple tables, and you need to make sure they are connected. And to make sure they are connected, you need to understand the process of doing that connection. And that is data modeling, and it is part of the transform data. All right. So later, you will have a quiz, and this question will probably be part of the questions, and we'll see who will get it right. All right. Now, this is where this is where we now get into the technicalities of data modeling. And after we discuss all these components and open our minds to understand them, then we have done justice to this lesson. Now, trying to make this whole lesson understandable, it has been a lot of work on my part trying to make everything simple. All right. And it takes a lot of time and effort to make the presentation understandable because there are some of these concepts, if you've not heard them before, if you don't have any past experience in them, even though you hear them, it is quite difficult to really understand them. And so what we are trying to do is to make everything as understandable as possible and very, very easy to understand. And so it takes a lot of time fitting these slides and these concepts in a way that we will understand. Today, we will not be able to complete all of them. And so in our next lesson, we will move to what we will be left with. And because of time, I want to complete my work to make it very easy for us to understand them because that is very, very important. And we need to do that. All right. So when we talk about data modeling, we need to understand that all of these components are very important. The first component in data modeling is your tables, of course. These tables are referred to as entities as well. So different tables are different entities. So we need to understand the concepts of tables and the details that come with what tables are in under data modeling. Because what you know already, maybe you've not paid a lot of attention to different types of tables, but when it comes to data modeling, we actually view tables in different types. And so we will get into that and we'll talk about two types of tables when it comes to building an effective data model. So this particular lesson is highly structured and it is something that you need to really open your mind and really understand. Right now, I am very sure that the definition of data modeling and why we need data modeling is very clear. What is left is to understand the following concepts. So we'll talk about tables and we will talk about relationships. Now, for each of these concepts and components, there are certain details that we need to understand. For example, when it comes to tables, you need to understand the types of tables. When it comes to relationships, you need to understand a number of things about what relationships are and the types of relationships we have. Also, there is something known as schema design, and you are going to learn something very important in Power BI and in data modeling called the star schema. Star schema. Please type that in the chat. So today I said you should be ready to learn new things. You should be ready to learn new things. And this is like the backbone of everything. And this is actually where the reality and the seriousness of Power BI really is. If you will really advance your use of Power BI, then this is the part that you really need to understand. So we will talk about the star schema and we will demonstrate the star schema. Then we'll talk about something that most of you are already familiar with. If you've done anything about databases, you are very familiar with foreign keys and primary keys, or let me say primary keys and foreign keys. So with that, I am sure that more than 70% of us are very, very familiar with primary keys and foreign keys. But I want us to type it in the chat again. Please type primary keys and type foreign keys. So these are the concepts that we are going to complete. And once we complete them, then we will be done with Power BI. Okay, so these are the main things to understand. And once our knowledge gets to that level, then we are really ready. Thank you so much. Thank you so much. When we get there, I'm going to find out those who already understand what primary keys and what foreign keys are. And as a data professional, you should be very good with databases. All right. And so we'll have a time and we'll learn about SQL. We'll talk about MySQL databases, and we will understand a whole lot about databases. We'll talk about what primary keys are, what foreign keys are, because they are the main ingredients for establishing relationships in databases. So very, very important. Then we'll talk about data types and formatting and the data modeling. And then we'll talk about DAX measures and calculated columns. Those we've already used them. So we are okay with DAX measures and calculated columns. And they are all part of data modeling. And if not for the project we've already worked on, they would have been a little difficult to explain. But right now, they are very easy. So if you follow our previous lessons, you understand what DAX measures are and what calculated columns are. Yes, calculated columns are. In our healthcare project, we created one calculated column. I don't know who remembers that column. Anybody who remembers the calculated columns we created one particular calculated column for the health project. I don't know if anybody remembers. You can put that in the chat and I'll look at it. Okay, thank you so much. And we will also look at what is called date tables or calendar tables. We'll talk about hierarchies and levels. We'll talk about data integrity and granularity. All right, so don't let these concepts scare you at all. They only sound technical, and what you have to do is to just relax and understand them. So far, every difficult thing about Power BI, we have understood. I'm sure that everything we've covered so far, we have understood, and this is what we have left. And what I want to assure you is that as we follow this lesson and follow the remaining lessons, we will understand them. So now let's pay attention and let's talk about tables. Let's talk about tables. Now, a table is actually what you are seeing. Let me share my screen properly so that I can write on the screen. All right. Thank you, Naomi, and thank you, Lucretia, as well. Thank you all, always. Thank you for following and making the classes so interactive and so effective. All right. So, of course, this is a table, and we understand that a table is a collection of rows and columns, and it represents an object or what is called an entity. All right. Now, I mentioned that there is a technical term in the world of databases for rows. Last time I asked someone, what is rows and what is columns? Something as simple as that. If you see a table, the grid, what is the rows and what is column? Are the rows the vertical groups of cells or the horizontal groups of cells? I was asking, and the person was so confused. So I don't know if someone is not clear about that. So who can tell me what is row? Are rows horizontal or vertical? Let me let me see. Okay, so are rows horizontal or vertical? I just want to understand. So I'm even getting different answers. Okay, all right. So when we say a row, thank you, thank you. When we say a row, this is a row, okay? So this is a row. So what I have drawn right now, I don't know if my drawing is showing. Please let me know if my drawing is showing. What I've drawn is referred to as a row. Thank you very much. And a row represents a single item in the table. So whatever the table contains, a row represents a single item, and every information in that row is talking about the same item. If the table is a student's table, then every item or data in all the cells represents the same person. The same person. The ID represents the same person. The name, the age, the program represents the same person. And technically, in the data world, especially in databases, we refer to rows as records, So I mentioned this yesterday, and if you have not typed it today, please type records in the chat for me because this is where the fun begins. So this is referred to as a record. So please keep this in mind. Okay, it's called a record. Sometimes you hear the term entries, but technically it is records, and you are going to be hearing records all the time. All right, and some of these things that we are learning, it is the same when you are learning SQL, the same when you are learning other courses. And so if you understand them, then other courses become very, very easy. So this is a record, and like I said, it represents an individual item. Then the columns are vertical. So this is called a column. This is called a column. And the columns also contain a single data type, and every data in each column is one data type. So for example, if you check here, you only see ages. You see 22, you see 24, you see 21, and each one is an age. Each one is talking about the same attribute. So we call these fields. Fields is a popular term, and also attribute as well. Attribute is also popular. So a column is called a field, and a row is called a record. If you can keep this in mind, it will help you a lot in a lot of courses and a lot of areas in your data career. All right, so these are fields. Please let's type fields in the chat. Let's type fields. So fields represent columns. Fields represent columns, you know. When you are learning things like Excel, we like to use the um, basic terms because a lot of people use Excel, and so we stick to rows and columns. If you're a professional, you are not going to be hearing rows and columns all the time. You are going to hear fields and records. And you have to understand when we say a field, what we are talking about, and records, what we are talking about. All right. Now, at the intersection of a row and a column, so this is a column, this is a row. Now, where they meet, a box is created. I don't know if you can see the box. A box is created right here. What is the name of that box? What is the name of that box? So where a row and a column meets, a box is created. What is the name of that box? And someone says it's called a cell. Wonderful. And Koleko says it's a cell. Ibrahim says it's a cell. Bernadine, thank you very much. So these are important, simple terms that we need to know as professionals. And it makes learning very easy if we understand this. All right. Now, in this particular subject of data modeling, we are going to learn about tables in a way that you have probably not heard before. This is why I want you to pay attention to this particular lesson. This is why I want you to really do your best and understand the concept in this lesson. And if you can do that, then you've mastered Power BI. We've done a whole lot already, and we are left with the most important part. Now, in data modeling, tables are the foundational component that store data or structured data. Each table represents a real-world entity. For example, students, courses, attendance. So when you are dealing with Power BI, every table is a real-world entity. Every table contains important data, and it's about a particular real-world entity. whether it's talking about students' profile data, personal information, or courses or attendance, or products or sales or orders. These are real world entities, and it is made up of fields and records. As you get professional, you stop using rows and columns. You'll be using fields and records, and fields represent columns and records represent rows. Now, in Power BI and in data modeling, a table can either be a fact table or a dimension table. All right, so this is new information, and in the next few minutes, we are going to take our time and digest this new information. Now, in Power BI and in data modeling, there are two types of tables. Your job tonight is to understand what in the world we are talking about and which table is a fact table and which table is a dimension table. So to begin this journey, I want you to type fact table in the chat for me. Fact table. Let me see the first person to type fact table in the chat. So Robley is always first. We have David and Kileko, Robin, fact table. So let's keep this in mind. And like I said, this is new information. So just take your time and digest it slowly. Now, if you have typed fact table, please type dimension table in the chat for me. At the end of this lesson, you will know what is a fact table and what is a dimension table in Power BI data modeling. Thank you very much, Jerome. All right, so over here, I'm showing you a picture of a fact table and a dimension table. So in a school database or an educational environment, we have several entities in our data collection. And we store these informations in different tables. Now, when it comes to student performance, we store performance data in one particular table. We store information about programs, about the student profiles, and about courses also in individual respective tables. Over here on this slide, I'm showing you two types of tables in education. Education is not what we are talking about now. In business, among your tables, some are fact tables and some are dimension tables. In this particular case, these two tables I'm showing you, one is a fact table and another is a dimension table. And as a professional, you need to know what is a fact table and what is a dimension table. Nobody's going to tell you, but when you look at the table and the data it contains, you should know whether it is a fact table or it's a dimension table. So what are we talking about? Like I said, let's take our time and let's digest them one at a time. Before I begin, I'm going to play a short video. And after the video, we will get right into the explanation of fact tables and dimension tables. So let's watch this shortly.
Now, generally speaking, data models will contain two types of tables. You've got fact or data tables and dimension or lookup tables. And you'll hear us use these terms, fact and data, or dimension and lookup, pretty much interchangeably throughout the course. Now, the way to distinguish between these two types of tables is that fact tables contain numbers, those numerical values or those metrics that you want to analyze or use for summarization or aggregation. So these are things you can count, right? Like sales, orders, transactions, page views, etc. On the other hand, dimension tables contain descriptive, typically text-based attributes that you use for filtering or grouping those values. So you might want to break down your sales or your orders by product, by customer, by day, by store, and so on and so forth. And dimension tables are what allow you to do that. So let's show a quick example here. This is an example of a fact table. We've got quantity values there in the third column, along with fields that give us information about those transactions or those quantities sold, the date they were sold, and the product that was sold. We might also have dimension or lookup tables like these. In green, we have a calendar lookup table that contains attributes about each date, right? So each row or record of this table represents one unique date. And if you know the date, you also know all of these additional attributes, like the day of the month number, the year, the weekday, and so on and so forth. Similar story with our product lookup table in orange. That table contains attributes about each individual product ID in that first column, because by definition, if you know the product ID, you also can figure out the brand, the product name, the SKU, the retail price, cost, weight, and any other product-specific attribute that this table might contain. Now, you may have noticed that there are some shared fields between these tables, and those shared fields or keys will allow us to connect or create relationships between them and form a proper data model. So for instance, both the calendar lookup and our fact table contain a date column, and our product lookup and fact table contain a product ID column. Because we have these shared columns or keys, that's what will allow us to break down those quantity values from our fact table using any field from either the calendar lookup or the product lookup table. So next up, we're going to dig into this concept a little bit deeper and specifically talk about the difference between primary and foreign keys. Stay tuned.
All right. Dimension tables are also referred to as lookup tables. I know that most of you have not gotten it yet, and so I'm going to take my time and explain this concept well because it is important to building effective data models. Without building effective data models, your Power BI project is not going to work. In Power BI data modeling, tables are categorized into two types. We have fact tables and we have dimension tables. To ensure effective data organization and efficient analysis. Without these tables, you will not be able to build effective data models, and this will affect the organization of your data and the efficiency of your analysis, especially when we are talking about real-world complex projects. All right, let's talk about fact tables. Now, a fact table is a table that stores quantitative data. Such as totals, counts, averages, quantities, amounts. So a fact table is a table that stores numerical or data that can be counted. By the time I complete all the slides, you will definitely understand. These tables contain numerical values that are often used to calculate KPIs. So in your Power BI project or data model, and when I say data model, I'm talking about projects that deal with multiple tables. Today, we'll be using Power BI, and so get your Power BI ready. We will demonstrate all of these things to make sure you have a clear understanding. Some of your tables contain numerical values that are usually used to create DAX measures and are used for calculations or to measure key performance indicators or KPIs. The tables that contain these type of values are referred to as fact tables. For example, this table is called orders table. So in a business project or in a retail environment, you are going to have one of your table called orders. Now, your orders table contain numeric values or contain events. Contain event. Please type events in the chat for me. Events. Let me see the first person to type events in the chat. Thank you, lovely. All right. What do I mean by events? What I mean is a table that contains something that occurred or happened, something that happened in the business. So when you get a new order, it is something that has happened. And the table that contains these events or what happened is a fact table. There are other tables, they don't store what happened, but they store descriptive information. Those tables are not fact tables. Those are dimension tables. So this particular orders table, it contains orders that took place. And it contains mostly numerical data that refers to other tables that contain descriptive data. For example, with the product ID we see here, we can connect this to the products table. And this is a really good time to mention this, that when you are designing tables for data and for databases, it is usually best to store IDs that will connect to different tables that contain the descriptions rather than storing descriptions in your fact tables. For example, it is wrong professionally to write the product name in this table. We don't do that professionally. What we would do is to store the ID of the product because we have another table that contains every information of the product. And all we need to do is to fetch the ID from that table and bring it into this table. And because of the ID, all the details about that particular product can be found when you have the ID. It is not right to use the name of the product. What if the name is edited in the main table? If the name is edited in the main table, what that means is that there will be duplication of data and inconsistencies. As for IDs, IDs are so powerful that they are used to identify items in a table. And so if you use an ID, IDs usually do not change. And so this is what will lead us into the concept of primary keys and foreign keys. We will get there. We'll get there. But since Ibrahim is so eager, the product ID column we are seeing here, is it a primary key or foreign key? Let me see what Ibrahim will say or anyone else. Is this a primary key or foreign key? Let me see in the chat. Is this a primary key or foreign key? Okay, Ibrahim is awesome. All right, so it is a foreign key. All right, it is a foreign key. So when we get there, we will talk about primary keys and foreign keys. Right now, let's take our time and understand fact tables and others table because I can feel that a lot of people are trying to understand this. All right, so I said the fact tables are the tables where we record events, things that took place, things that took place. And they are usually numerical values within those tables. So examples, sales are events. Somebody bought something. So the sales transaction records each sale made. Such a table contains columns like order ID, product ID, quantity, sales amount, discounts, and these are usually numeric values. If you are a data professional, one of the fantastic skills you must develop is to know how to design tables. Now, these tables here, we are telling you the columns, but are you able to engineer the columns by yourself? If you're also a software engineer, you need to know this because when you are working on a project, let's say building an e-commerce website, you have to engineer all the tables. This means you have to know what tables we will need for our database. You have to know the kind of fields or columns to use for each single table so that relationships can be done right, so that the tables can talk to one another, so that we can capture every relevant data in the organization. If you are building a project for a school, whether a web or software project or a data project, you need to, by yourself, have the skill to create the tables. The tables are not going to be given to you. So knowing the type of tables you need is so powerful, and knowing the fields you will need for those tables are so powerful. So let me give you an example. If you are building an e-commerce project, by yourself, you need to enter into your planning world and your dream world and to understand that in this project, I will need a table to store my customers. So I need a customers table. What other table will I need? I'll probably need an orders table. What other table will I need? I'll probably need payments table. All the tables you will need, you need to know them. You need to know them. And for each table, you need to create those fields. You need to create those fields. You need to create those fields. Let me take a second and see if I can find a picture and show you. Just for a second, if I don't find it, we'll just continue. All right. So I just went online and I found a table or the picture I'm looking for. Look at this man. He's a data professional. What is he doing? He is designing the a database, all right? By himself, he has come up with all the tables he will need for his project, and he has come up with all the fields needed for each table. This is what I'm talking about. You have to know that for this e-commerce project, you will need a products table because there should be a table that stores products. You have to know that you need customers table. Nobody is going to tell you. You have to know that you need orders table. Then under each table, you need to know, yes, you need to know what fields will be needed. What fields will be needed. And you need to create those fields. After doing this, you need to know how to establish your relationships. Now, these things are so natural. If you don't get what I'm saying, it's just because you are still learning and you are still getting closer to being a professional. But once you become a professional, these things are so natural. You just know them. All right. You just know them. So wherever you need to create a foreign key, you will see where you need all your primary keys. You can see that almost all the tables have primary keys. And you can see that where foreign keys are needed, they are created, and you can see the relationships being set up. You see, so this is actually done on the drawing board first before you get onto the computer to start creating them. This is an incredible skill to have. All right. So still talking about fact tables, we mentioned that fact tables are tables that contain numeric data about events that happened, and they are usually numeric data, and they are usually what is used to measure KPIs. For example, we'd like to know our sales. This is important KPI in the organization. We'd like to know orders. All these are events. Is payment an event? Is payment an event? Anybody in the chat? Is payment an event? All right. So someone says that yes, payment is definitely an event. And so you have to know, and you need to answer this question. Is a payment table a fact table or not? What do you think? Is it a fact table or not? Okay, so it is. All right, thank you so much. All right, so I'm going to take my time and explain this, and I'm actually going to take my time and explain this, and I'm going to make sure everyone understands it. Okay, so let's talk about dimension tables. A dimension table is a table that stores descriptive information, such as names, categories, dates, and other details that describe the data in fact tables. So before now, you have just been seeing tables, but today we are telling you to look at tables differently. Start asking questions. What type of table is this? The same table you've been looking at. Start asking those questions. Is this a fact table or is this a dimension table? Dimension tables provide the context needed to filter, group, or label the numbers during the analysis. So for example, in your fact table, you may see order ID or product ID. This means there is a different table that contains a product description where you will find the product name, you will find the product age, the product description, the product model, the year of manufacturing. You'll get to know every detail about the product, every information. All right. So this table called products, look at it carefully. Is this a fact table or a dimension table? Is this a fact table or a dimension table? All right, so the first person says that this is a dimension table. This is the new information we want you to acquire tonight. After this lesson, you are going to learn something that is really important, really valuable, and will really build a prerequisite for higher education in working with data and databases and tables. All right, so this products table is a dimension table. So we have the products table describes each product in the catalog. So the product already exists. Customers already exist. One customer can make several orders. So the customer table is a dimension table, contains details about the customers we have, not the orders. Employees contain the details of our employee profile information, such as their product ID, their full name, department, age, the date they were hired, and a whole lot. Key differences. A table that records sales transactions with columns is a fact table. A table that contains products is dimension. A table that holds customer information. What do you think? Customer information. Is it fact or dimension table? All right. So customer information is definitely a dimension table. Okay, you got it. All right. So we'll be doing some Q&A to see who really got it. Now, the fact table holds what happened. So just like I explained, they hold events. And the dimension tables describe who, what, where, and when those events happened. All right. So they are the description of the fact table. You'll get it very soon. So we're going to begin our demo and we are going to start working with an education data set. And we are going to follow this education data sets, multiple tables, and at the end, create a powerful dashboard or report that will just blow your mind and take you to the advanced levels. So we are going to start this systematically one step at a time, and it's going to be a long process of dealing with these data sets in multiple ways and making revisions. So make sure you don't miss anything. Make sure you follow. And at the end of the day, what we will end up with is going to be something massive. All right. So in an education data set, I'm going to show you some data sets, and I want you to identify which ones are the fact tables and which ones are the dimension tables. All right. So what I'm going to do now, let me see if I have this right here, and I have them right here. So let me know if you can see this. Let me know if you can see this. All right. Okay. Thank you. So, all right. This is one data set, and it contains programs and students information. Let me just open them so that we start exploring the data sets. So I open to this, and it should open in Excel. And over here, we have this data set here. And if you check the sheet, you can see that this is programs. And these are actually Rate Africa programs. And we just want to have some fun with our own programs. So in the whole organization, you can see the programs here, and each program needs a primary key, product ID, or program ID, then the name of the program, the duration of the program, and if you do not know, we are switching to 18 months to make sure that you get a full career training and quality training. So a lot of information and announcements will be made very soon if you are not aware. All right. Then we have these columns or fields in this particular table. So this table is programs. And what is going to happen is that sometimes one file may contain multiple sheets. One file may contain multiple sheets. And so each of the sheets will provide a table. And so you are going to work with different tables that came from a file. So in this particular file, I have intentionally placed two tables, and each of them will be downloaded separately into Power BI. Now, when you get to the students table, you are going to see students here, and you are going to see up to you are going to see up to 1,000 students. All right. So this is not a real data set, but it is a pseudo data set that is modeling the same concept. And for Rate Africa to be very effective, we need 1,000 students in our program. All right. And so let's all be parts of building the community, and we are working hard to make everything so perfect. So let's all be part of building the community and bringing people. Let's have our 1,000 students in the program, and it will help us get all the support we need. All right. So that is the students table. And let me move on to another table called education courses. And all right, so over here, you can see the fields, and these are different courses in the different programs, different programs. And over here in this particular table, you can see that we have course ID, we have a course name, we have program name, and we have course order. As a matter of fact, because Okay, first of all, this type of data, is it a dimension table or is a fact table? Let me see if someone will get it. Is this a fact table or dimension table? All right, so this is dimension. All right, thank you, Bernadine. Yeah, always smart. All right. Now, one thing here that sometimes is done very easily because of working with spreadsheets. Usually, when you are working with databases, you don't do that. You see, Excel doesn't have this automatic relationship building. And so most of the time, instead of storing IDs, people tend to store text. So here, you know that this belongs to the cybersecurity program. But in a real database, Excel is not a full database. Excel is actually called a spreadsheet. So because this is a spreadsheet program, we sometimes store the text. But in a database environment, instead of this program name, we are going to use program ID as a foreign key and link it to the programs table because we have a programs table. And later on in this particular lesson, we may change this to help us establish our relationships right. But for now, let's work with this and we are going to learn how to make all these changes as part of the learning process. So we have 4 files here and this is attendance and we have 5 tables in all. So the first thing I want you to do now is to download all of these tables. Visit github.com/RitaAfrica and please download these now. If you have downloaded them, let me know in the chat. So go to github.com/RitaAfrica and then hit enter and go to Power BI datasets. Click on Power BI datasets and look for them right here. So these are 4 Excel files. Please download them right now. If you are watching this video, just go to this link and you will find the data sets. All right. So instead of typing in the comments, where can I get a data set? Please go to github.com/RitaAfrica. Then click on Power BI dataset, or you can type it in the URL at once, and you'll have access to all the data sets right here. To download the data set, click on any of them. Once it opens, look for the download button wherever you find it. If you come up here, you can see 3 dots. Click on the 3 dots and you can see download right here. So once you click on download, you will be able to download right here. So download all the files and let's use them in our demonstrations. All right. So now that you have seen these tables, we are going to discover that among the 5 tables or the 4 files, this time we are referring to the tables, 2 of them contain fact tables. So the attendance is a fact table because it contains something that happened, and the performance is also fact table because it contains events. All right, so these 2 are fact tables within the tables I gave you. And by the time we complete everything, I'll make sure you have this concept right because this is important to building effective data models. All right. And so when you open to the attendance and performance, you are going to understand that these are fact tables because they contain measurable and quantitative data you use for analysis and KPIs. So performance is good KPI that you want to find out, and attendance is also good KPI you want to find out. If you have an education, a school, and you want to monitor what is happening, Of course, performance is a good KPI you want to find out. Attendance is a good KPI you want to find out. In this particular context, we are beginning our project already. This data set, we will work with it till we actually work on a major product. Thank you very much for downloading. So the attendance and the performance contain measurable and quantitative data used for analysis. And you can see the kind of fields they contain. The attendance contains student ID, course ID, date and status, and they can be used for measures. Attendance status can be used to calculate total classes, attendance rate, etc. Then we have the performance table here. It contains student ID, course ID, score, grade, test date, and it measures score, grades, useful for performance tracking, average scores, and all of that. So average scores, performance tracking, GPA, and all of these things, they are important KPIs, and the table that contains them are fact table. So after we use these for examples, you are going to understand fact tables in general. Now, we are going to start importing them into Power BI, and we'll import the fact tables first. We said the fact tables are who can tell me the tables we have in our current project, our education data sets, which ones are the fact tables? Let's take it to the fact tables first, and we are going to import them into Power BI, and then we will go ahead and import the others. So the fact tables are attendance and performance. Thank you, Benedict. So let's launch Power BI now, and let's get started importing our attendance and performance. I'm going to start with attendance first. All right. So when you open to your Power BI, you can go ahead and select a data source right from here, or you can start with a blank report. Any of them works. We've always been starting with a blank report. Maybe not to confuse anyone, let me just click here, but I was going to click on Excel workbook because it is a data source so that I select my files. Let me go to blank report, and after that, I move to get data. So I move to get data, or instead of get data, I can just select this one, Excel workbook, because this is all about getting data. All right, so let me click on get data, and Excel workbook is also here, the same thing. And I'm going to select my attendance table. So please watch what I'm doing and make sure you do same. After you download them, the attendance table is titled 3 Education Attendance. So let's import this. I'm going to open to this. And once it opens, we will get the data preview right here in the navigator. And we will be able to select the table right here. So the table is attendance. Once you click on it, you get a preview at the right. And one thing about this navigator and the preview is this. The preview has been truncated due to size limits. This means that Power BI limits the size of the preview. This is just a preview, and so you don't need to see everything. In Python, if you want to see head by default, how many rows do you get by default in Python? You get 5 in pandas, all right? You get 5. Now in Power BI, you get 200. So this is not everything. So if you can't see all your data, don't worry. All right. Now, because we have done a lot of transform, we are just going to move straight to load because this lesson is not in Power Query. So let's click on load, and we are going to import our attendance table right here. Let me close them so that there wouldn't be any effects on them. It's not going to do anything, but in Excel, I'm just closing them. So I've been able to load the attendance table well. I can tell because in the data pane, I can see attendance right here. I can see this. All right. Now, if you have done this, please put 1 in the chat for me. If you have done this and you can see attendance, please don't import any yet. Let's follow the lesson systematically so that everyone will understand the concept of fact tables and dimension tables. All right. Now, if you have done this, this is what I want you to do next. I want you to rename this table by double clicking on it or right clicking and go ahead and rename it wherever you get a box. Type this. The cursor has moved here, but I'm going to bring it back and I'm going to type, okay, again, I'm going to bring it back and type it well. Type fact attendance and hit enter and go back there and check if it has renamed. If you have done this, type 2 in the chat. Type 2 in the chat. All right. Thank you. Now, in advanced projects, you are going to see most of the tables having this pretext. You will see your tables either fact something or dim something. Fact something or dim something. And if you are a professional, you are going to understand what we are talking about. So seeing a table starting with dim, you are going to be thinking, why is this table starting with dim? Okay, if you see that, what do you think is the reason why the table has a pretext called dim? Who can tell me why a table will be named like that? All right, so a table is going to be named like that because we want to note the table or name it as a dimension table, and we want everyone to know that it's a dimension table. So in a large scale environment, for easier identification, thank you, Robley. In a large scale environment, this is how you are going to see your tables. You may be working on a project with over 20 tables, and all you see is dim products, dim students, well, or dim customers, dim something, or fact something, fact something, fact sales. It is just telling you that this is either a fact table or it's a dimension table. All right, so we are not done. Let's bring in the performance and please do it by yourself. And if you have this preview, then post this in the chat for me. So import the performance. And if you have this, this means just go to model. After you rename, go to model view. After you rename, go to model view right here. And if you have this screen, capture it and post it in the chat. Let me know. We are starting a very powerful project little by little. It's going to take several steps, several learning iterations, and we are going to get a lot out of this. So thank you, Lucretia. You are amazing, amazing. Thank you. This is beautiful. All right, so Ibrahim has done it. Lucretia, Robley, thank you. I love this. I love this. I love this. Okay. So I think Ibrahim, you are left with your performance. I can't see your performance. So please fix that, Ibrahim. Inkoleko, thank you so much. Your work is quality. Lois Ominde, always. Lois is amazing. Thank you. Thank you all. All right, so let me just do mine quickly. And of course, Bernardine has represented. Let me do mine quickly. So I look for performance. So I'm going to load my performance table. So I can just click on Excel workbook and I will look for performance and I will open it. Once it opens, I see the preview. Click on performance here. I see some of them. And then I go ahead and I click on load. I go ahead and I click on load. All right. I go ahead and I click on load. All right. So next, after loading, just like I asked you, I'm going to rename this. I'll right click and I'll select rename and I will just rename it. So just call it fact performance, enter. And let me go to my model view. Oh my God. I'm really loving this course. I'm really loving this course. And let me collapse these properties for now. And let me arrange this a little bit. Make sure the scroll bars are gone. I mean, it's nothing. It's just for fun. And what I'm seeing right now, I'm going to check. I'm going to check here. It looks very similar. So if you are not seeing this clearly, one of this is my real Power BI, and one of these is my Excel, sorry, my PowerPoint slide. All right, so this is my PowerPoint slide, and everything is the same. All right, so we've already done the demo. Let's move on. Now, a fact table stores measurable data or quantitative data. So the definition of a fact table is that a fact table stores measurable data or quantitative data. Usually the data in the fact table is used for measurement or for counting or finding KPIs, the numbers you actually want to analyze to get to know how many in terms of the events that took place. It contains facts or metrics like sales amount, exam scores, attendance, hours, etc. It also includes foreign keys that link to dimension tables like student ID, course ID, etc. And for an example, a table called performance may include student ID for us to know which student we are referring to. All right, for us to know which student we are referring to. So when we get to the concept of primary keys and foreign keys, you are going to understand that. We'll treat that separately. But a foreign key is a key or an ID that can link to an original table and help us identify a particular record. Okay, so in this performance table, instead of storing the student's name, you store the student ID. That ID is an identifier and it is called a foreign key. Why is it not called a primary key? It's not called a primary key because where we find it now is not in the student's table. In this table is not the student's table. This is a different table, and this table is the performance table. But the performance is talking about students. And so the student ID you are seeing here is called a foreign key. But this same key inside the student's table, if you see student ID in the student's table, this time it is called a primary key. But if that key is found in a different table, it is called a foreign key. So we'll take a look at that as well. So think of a fact table as a collection of events or transactions, things that happened. When building a data model in Power BI, which we are going to do, any table that contains numerical values that you want to analyze, such as totals, quantities, or metrics, is called a fact table. And any table that provides descriptive information to give context to those numbers, such as names, categories, or date, is called a dimension table. The fact table holds what happened, and the dimension tables holds all of this that we've talked about already, talking about what happened, the who, the what, the where, and the when. If you have a table that records students' test scores, study hours, or attendance, that is a fact table. It holds the actual results or measurements. If you have a table that describes the students themselves or the courses details, those are dimension tables. They help add meaning to fact tables. So in this project, we also have dimension tables, and we have our programs, our students, and our courses. Those three tables are dimension tables. Here, I'm just showing you two of them, the programs and the courses, but there are three dimension tables that we have. All right, so I'm sure these are clear. The programs and students table contain these fields and includes the students' details, and the course table describes each course with the names and order used for categorization and reporting context. So I'm sure that is fine. So the next thing to do is to import the remaining three tables and name them DIM students, DIM programs, and DIM courses. So please do this and post this in the chat as well. I want you to do these three and post them in the chat as well. So we are following this step by step, and we will learn a whole lot, and we will understand what is left to understand in Power BI. All right. So let me see this. Take your time and do it, and please share this in the chat as well. All right. So let me just go ahead and do it while you also do yours. There are three tables. So let me open to Power BI, and I will just load mine. So over here in this file, we are seeing two tables in one file. When you click here, you get to see the programs table like this. And with this one, you get a preview of the students. Even though there are 1,000 students, you can see that we only have a few. So I'm going to load both of them. I'm going to make sure both of them are selected over here. Make sure you select both of them. After clicking, you get a preview for each one, but select both of them and load both of them. So let's see how it loads. And the two tables are going to be loaded right here. And, okay, okay, all right. So let me collapse this for now. And you can see what is going on here. You can see what is going on here. Okay, so please, if you can see these things, who can tell me what is happening here? What is going on here in our model view? These lines that are now connecting. Okay. All right. So you can see the lines already connecting. Whoa. That is interesting. Hmm. Okay. So after we understand tables, the next thing we are going to learn is called relationships. And these lines we are seeing here are relationships. Just like in real life, people who have something in common usually have relationships. And so Power BI looks at the tables, and when it sees something in common, it establishes a relationship. Now, this relationship is done automatically. And this relationship is done by Power BI on Power BI's own intelligence. However, you are the data analyst and you need to ensure that the right relationships and the right cardinalities are established. And this process of doing this right is what we call the data modeling. And so this is going to be core to what we are going to be learning in this lesson. And Power BI has done these relationships automatically. Now, when you put your mouse on any of them, you are actually going to see which fields Power BI used for the relationship. So over here, I'm going to see that the fact table attendance was linked to students, okay, was linked between student ID from attendance and student ID in students. This relationship was done between student ID and student ID, and this one was done between program ID and program ID. Wow. Wow. All right. All right. Okay. So let me go ahead and name my students table. I'll do that right here. I'll double click on it and I'll call this dim students. And let me do same to programs. I'll double click on this and I'll call this dim programs. All right. So this is how you are going to see the tables named. And I think I'm left with one more table. So let me bring that in as well. And that is my courses, I think. All right, so I'm bringing in my courses and let me check this. I see the preview, a lot of courses, and I'm going to load. So after loading courses, I'm going to see a more complex relationship being set up. Wow, this is getting interesting. And this is the data modeling we are going to learn about and understand. This is amazing. All right. So, all right. So when you look at this, you are actually going to see a lot of relationships. I want to find out a relationship between courses and performance. So we have course ID and course ID. That's what I'm seeing now on this link. And let me check between programs and courses. It did it with program name. All right. So please watch this. Okay. We've not gotten to relationships yet, but I want to show you something. Please watch this. This relationship, what fields were used for the relationship, for establishing the relationship? The program name, okay? Now, tell me the difference between the relationship line or the link here with the others. What is the difference you see? What difference do you see? Please tell me what difference you see. Okay, so this one you see dotted. Now, I'm going to tell you that the lines are broken because this type of relationship is not recommended. It's not recommended. All right. Even though it is working, but to build an effective model, this relationship is not recommended. So we included this intentionally so that so that you will understand these kind of things and we will correct it later on. So please, who can tell me why this relationship is not recommended? We've not gotten to relationship yet, but please tell me why this relationship is not recommended. All right, anybody? So this is a question to the class. Anybody? Exactly. It links text values in Koleko. Thank you. Thank you. Now, usually relationships are best created on primary keys and foreign keys. This means they are all IDs. Instead of using the IDs, here we are using the program names. Program name. All right. So I'm still going to maintain this error and we'll continue with the lesson. When we get to relationship, we will fix this. We will fix this when we get to relationships. All right. Now, we will also create this relationship like this to also explain relationship. For now, we are going to maintain this. All right. So please, if you can hear me, I want you to manually delete all the relationships. Right click on the links, the relationship lines. Are you sure you want to delete? Yes. Delete all the relationships and let's learn about data modeling manually because before we learn, we don't want Power BI to establish a relationship for us. As professionals, we want to establish a relationship ourselves. So right now, I want you to delete the relationships. And this is to let you know that you can delete relationships in Power BI. All right. And arrange your tables like mine. It doesn't matter, but just do it. All right. So I'm not done, but someone should tell me what I'm left to do. What is wrong? I'm left with something, one thing, just one thing to do. Who can tell me what I'm supposed to do? Look at my tables and tell me one thing that is missing from the instructions I gave. What is missing here? All right. So check this and tell me what is missing. All right. Thank you, Bernardine. Bernardine is so fast. So let me come to courses. And you are telling me to call this dim courses. So I'm going to ask a question. Are you telling me that you have understood fact tables and dimension tables already? I want to know. Are you telling me that you've understood it? Oh, wow. Oh, wow. I love Rita Africa. You see, these are complex things that other places, they will spend a long time explaining, but you have already understood them. All right. So that same way, you will understand all the concepts and everything is going to be perfect. All right. So this is fine. If you have this, the naming done right, and your 5 tables, please take a screenshot and share with me in the chat. Share with me in the chat. Let me see the first person to share. If you have this, delete the relationships and just share with me because we are going to learn how to establish relationships. All right, Nkuleko, thank you. Perfect. Samuel, great. Awesome, 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 awesome. All right, so this is exactly what I have in my slide. This is not Power BI, this is my slide. And we've done the demo. And dimension tables store descriptive information, the context about the data. It contains attributes like names, categories, locations, dates. Dimension tables help us understand and slice the numbers in the fact table. For example, a table called courses that includes course ID, course name, instructor name, program type, duration. It's a dimension table. And this time you can see that this is called primary key. Primary key. So by the time we are done, the concept of primary keys and foreign keys, you will understand them very well as well. Think of dimension tables as the who, what, where, and when that describe the facts. How they work together. The fact table connects to multiple dimension tables through relationships in Power BI's data model view, enabling powerful analysis like total score per course, average score per student, total attendance per program. Beautiful, beautiful. The structure forms a star schema. This is another terminology that we are going to learn about under data modeling. Remember the components I introduced to you? There was something known as schema, and we are going to learn something new in Power BI called star schema. All right. These are important concepts and important components of Power BI. Although they may sound technical, you will understand them. And they are important to understanding how to work on big projects, enterprise level projects. And after this course, you can take on any organization in the world and build their business intelligence report and dashboard. All right. So because of time, I think we may have to postpone the relationship aspects to another lesson. But I wish we had the time to go through it because it is the heart of data modeling. But let me ask the class, should we move this to the next class? Because we will spend some time talking about relationships. So should this be moved to the next lesson? Let me know in the chat what you think. Okay. So let me know. I just want to know from you. Okay. So if you want us to continue, please type continue in the chat, please. If you want us to continue, type continue in the chat. Okay. All right. That's fine. That's fine. Okay. All right. So let's give ourselves about 45 minutes maximum and we'll be done. All right. Let's continue. Okay. We have a lot to cover. Let's continue. We will get it. And in the next class, we have other concepts to look at so that we complete the data modeling components. Okay. All right. Okay, if we are continuing, then let me give you 5 to 10 minutes break and we will continue. So don't go anywhere. Don't go anywhere. We are going to continue. So just stretch, get up and stretch, and we will continue. So just a short break. All right. So welcome from the break. Welcome back to the lesson. And we want to continue from where we left off. And this is time to delve into relationships. Relationships. If you're excited about relationships, let me see it in the chat. Please type relationships. And this is the heart of data modeling. And this is the heart of this particular lesson. And we want to take our time and explore it. In this lesson, we have understood the importance of data modeling. We've understood that if we don't understand this lesson called data modeling, we will be limited in the kind of projects we can work on. We've been able to build fantastic reports in retail. We've been able to build an amazing healthcare report. However, without this lesson, we are not going to be professionals. And so we want to really understand this lesson. And this particular subtopic on relationships is the heart and soul of data modeling. And this is what we want to take a look at next. All right. So what is a relationship? A relationship in Power BI is a link. Please type a link in the chat for me. It is a link. Please type a link in the chat for me. It is a link. Let me see a link, a link, a link between two tables, a link between tables, a link between tables. All right, between tables. So it is usually between two tables because from table A, there is a relationship to table B. It is possible that table A also has relationship with table C, but the relationship is really between table A and table B. Just like in marriage and in real world relationships, there is always something common between the two tables. And it's all about two people. Now, most of us in this class may have relationships with one another. You may have a relationship with one person in this class. At the same time, you have a relationship with another person in the class. But this relationship we are talking about is actually between you and someone in particular. So it is a link between two tables that allow data from one table to be used in combination with another table. Relationships connect two or more tables based on a common field. Please type common field, common field. So when two people find out that they have something in common, most of the time they are drawn to one another and relationships begin. One day I was so shocked. I was so shocked that I was invited to a wedding. I was shocked. I had no idea. This year I've been teaching for 10 years. And when I got an invitation, I realized that it was between two of my students that I never thought that anything was going on. I never, in 1,000 years, I couldn't have even imagined that these two people will have something going on. But they were getting married and they invited me and gave me a seat on the high table. This has happened a number of times. And maybe one day at Rate Africa, we may hear such news. Maybe Bernardine will be announcing such news that so and so is getting married to so and so one day. Maybe. But then they have something in common. And this is talking about a common field. All right. So relationships connect two or more tables based on a common field. Now, why are relationships important? Without relationships, Power BI cannot pull in related data. When two tables have data that are related, Power BI cannot pull data from these two tables. Example, a student's name and test scores. So we may have the test scores, and you can see that in the test scores, we have student IDs. We should connect to the students. But because we are talking about multiple tables, the test scores will not be able to pull the data from the students table. And so in your report, when you click on a test score or when you click on a student's name, it does not reflect in the visualization. It doesn't reflect. Your slices and your filters will not work correctly. You will have duplicate or missing data in your visuals. So this is why relationships are important, because with relationships, Power BI knows how to match one table to another. Power BI knows how to match one table to another. You can analyze across multiple tables smoothly. This is why relationships are important. Now, we are going to go through a number of challenges just to help us understand the concept of relationships in Power BI. So number one, we are going to create a visual that works with our relationships. And we are going to ask the question, why did this work? Why did this work? So we will go to Power BI and we are going to follow this instruction to create a relationship, to create a visual, sorry, we are going to create a visual and we are creating two visuals. Let me create it first and then you follow. So first we'll create a bar chart. We'll create this bar chart and it will be created on program name and course ID, okay? And the table we are going to use is called dim courses. Dim courses, don't forget. So let me start again. We are going to use this table, courses, dim courses, and we are going to create two visuals. We'll create a bar chart and we'll create a table visual. There is a visual called table. We'll create that as well. So when we get to the bar chart, these are the fields we are going to use. Please take note of them. I'm going to be asking you when I leave this slide. When we get to the table visual, these are the fields we are going to use. Please take note of them. I'm going to ask you when I leave this slide. So let's go to Power BI. Let me create it first, and then you will do the same. So I'm going to open to Power BI, and let me know if my screen is still visible. And I'm going to move away from the model view. Please take note that we don't have any relationships. And please, if you have relationships, please delete them for this demo to be effective. So no relationships. Let's move to this view. This is called our report view. I'm going to click on my report view and I'm going to create two visuals. So the first visual is going to be a start bar chart. I'll create it. Let me expand it like this. And I want you to do the same as well. And this bar charts, what are the fields? Okay, first of all, what is the table I'm going to use to create this demonstration? What table am I going to use? Let me know in the chat. What table am I going to use? I'm going to use dim courses. Thank you. So out of dim courses, what fields am I going to use? These are the fields. What fields am I going to use? What fields am I going to use? So I asked you to take note of them. All right. So I'm going to use the fields called course program name and course ID. So this is all I will do. This is all I will do. I will click on course ID and I'll click on program name. Let me check if my visualization is created right. Okay. Now, if your visualization is created right, then no problem because Power BI does a lot of things automatically, and this is correct. Now, if it wasn't right, then I will come to the data portion and I will place program name under the y-axis and I will place the courses ID under the x-axis. So this, I can move them manually, but Power BI detected it based on the visualization I selected and it created it. Now, this is working because when I click, you can see that it is moving and you can see that one longer than another. So it tells you that the values are working all right. Let me create a second visual to prove this point. There is a visual called tables. So let me look for it. So these are all the visuals in Power BI, and there's one of them called tables. I'm going to use that. So I'll click on it and I'll use it over here. Now, in the table, I'm going to use the same table called courses, and I'm going to use the same fields, course ID and program name. Now, let me, first of all, remove this filters area to get more room. And let me increase the font size. To do that, I'll go to this properties and I'll go to values and I will just increase the font size from here. So let me see what font size will work and I'll just leave it. All right. So this is okay for now. We can all see. So right now, you can see clearly that we have a table visual here. And this table visual, you can use it in your report. Sometimes in your report, you can show a table. And this is accurate. It is working because you can see that the number of courses per program, this is program name, related to number of courses. It has been able to find out how many courses we have per this program. And this is good information because we know that they are different. So this means it's working. And we can see the total here. Now let me click on cybersecurity and you can see that it had an effect on this visual. When I click on data analytics, it had an effect. Data science and machine learning had an effect. Cloud computing had an effect. DevOps, full stack web development, and software engineering. You can see that this is working. All right. So let me ask the question now. The filters here are working and there is no relationship whatsoever. If you go to our model view, there is no relationship. Who can tell me why there is no relationship and it is still working? Who can tell me why in the chat? Why is it working even though there's no relationships? Why is it working even though there are no relationships? Because we are working with a single table. Thank you so much. You guys are smart. All right. So Robley got it right. Lucretia got it right. Nkululeko, I like the way Timothy pronounces it. Nkululeko, Ibrahim got it right. Bernardine, of course, got it right. So this is working because we are working with a single table. So quickly create this and share the screen in the chat with me. Please create what I've done and share your screenshots in the chat. Okay, we are talking about relationships. This table is a single table and it's able to move around with no relationship because it has all the details it needs within itself. But in real projects, in advanced projects, you are not going to pick information from one table. You are not going to pick information from one table. So even though this is not working, even though this is what we know so far, this is not enough at all. All right. So thank you all. Thank you all. You've all done it. You've all done it. Beautiful. All right. So this is just for demonstration. We will try it later on. All right. So on my slide, you can see that this is exactly what we have created and this is working. All right. Now, the expected outcome, both visuals will render successfully. No relationship is needed because program name is already included in dim courses table. The table is self-contained. This type self-contained, self-contained. So this table is self-contained. This is where you got the self-contained rooms from. It's self-contained because it has the program name within it. So it's a solo table, a single table. All right. But in a serious project, you are not going to be working with solo tables. So I'm telling you, we are going to intentionally create a visual that will fail. We're going to fail that our relationship fail. Let's intentionally do that. So I'm going to do it and I'll let you do the same. All right. So here I'm going to use two tables. Please take note of two tables and we visuals and I have so the tables and like this table will be the performance performance. We're going to use our program table which is programs. And we are going to create two visuals, a bar chart and a table visual, just like we created. The bar chart is going to come from the programs table. Please take note of this. And it is going to contain the program name from the programs table and the values will be the score taken from the performance table. So here we are measuring programs and their performance, not students and performance yet. We could have done that. And maybe I will ask you to do it as an assignment later. At this time, we are working with program and performance. So let's do this. Take note of the tables we are going to be using and the fields. So first off, we are going to start with the programs table. And we are talking about program name and score. So let me go to Power BI. Let me do it first and you do the same. So I'm going to move to page 2. I'm going to leave this here at page 1. Page 2, I'm going to create a bar chart visual again. The same bar chart visual. I'm going to expand it to half of the canvas. And who can tell me the table I'm going to use first? Let me collapse this. Let me collapse this. I'm going to use the programs table first. All right. Programs, sorry, I'm using programs first. Okay. And in programs table, watch this. I'm going to select program name. Then I'll move to fact performance. And here, what field am I going to select from here? I'm going to select score. All right. So let's see the visual I have created. So this is where the lesson really is. Who can tell me something strange that is going on here? Look at the first page, what we created, which is right, and it's working. Look at this one here. What is strange here? Just by looking at it, What is strange here? What do you see? What do you see? And I'm not going to click on it. I'm just telling you, asking you to tell me what you see. All the fields are equal, and that is strange. And that is not accurate, Bernardine. Thank you. It is not accurate. It's not possible that they all have the same scores because I selected programs and scores and they are all the same. That is not true. All right. Let me go ahead and create my next visual. The next visual is called a table visual. So I'll click on table and I'm going to select the same fields. Under programs, I'm going to select program name. And under performance, I'm going to select score. All right. Let's look at the table we have here. And something is fishy right here. Let me go here to the formatting, go to values, and let me increase the font size again. And let's check something. So I'm increasing the font size and something looks fishy. So what happened right here, this is where we are seeing it for real. So please look at this table and tell me what is going on. What do you see? What do you see here? What do you see? All right. So all the scores are the same. These are programs and they are scores and they are the same. So this is a type of error you are going to get when there is a relationship problem. The records or the data or the scores we are seeing here are all going to record the same scores. Meanwhile, that is incorrect and not accurate. So this is why we said without the right relationships, your analysis will be incorrect. What if you base your analysis upon this? And we are talking about the importance of data modeling because this is what is going to happen in the real world. If you base your analysis upon this, would the analysis be correct? Will it be accurate? Will it be accurate? If you base a serious analysis on this, no, it will not be accurate. All right. My next question is that why do we have this happening? Why is this happening? Why is this happening? Why do we see this? This is incorrect. Why do we have this? Yes. Thank you, Robley. Thank you. All right. Because someone says the relationship is not working. All right. Okay. So please, for challenge 2, I want you to create this, please. Create this and post it in the chat so that you experience this yourself. All right. I want you to witness this and experience this practically yourself. Do this and post this in the chat for me. Take a screenshot and I want to see this in the chat. All right. So Robley is done. Robley is done. Perfect. Perfect. Thank you. Francis is done. Ibrahim is done. And Kolako is done. All right. Okay. So instead of telling you, I want to show you. Okay. This is an example of the errors you will have in your analysis when relationships are not established. This is why I like this lesson so much because we are getting a practical feel of everything. All right. So let's go back to, let's look at the outcome. These visuals will not render correctly or will show blank or incorrect data because there's no relationship linking the tables. Beautiful. So after doing it, this is the same thing we saw and we are moving to challenge 3. So in challenge 3, please watch this. We are going to establish the relationships. Let me do it first, and then you go ahead and do the same. All right. So to establish the relationships, we are going to move to our model view, and we are going to create the following relationships. First, we will talk about the fact performance table and the dim courses table. And we are going to establish relationship between course ID and course ID. So I want you to take note of performance and courses. Let's do that one first. Let me finish and you do yours. So performance and courses, let me see them in Power BI. And I can find it in the model view. This is performance, and where is courses? This is courses. Okay. And what fields are we using for the relationships? Who can tell me the field we are using to establish a relationship between performance and courses? Facts performance and dim courses. Mr. Performance and Miss Courses. All right, we are using course ID. All right, so to do that, you will drag course ID from here and drop it on course ID from here. All right. When you do that, you see this new relationship dialog box, like a wedding going on. And this wedding ceremony is telling you that Mr. Fact Performance is getting married to Miss Dim Courses. Now, what do they have in common? You are going to see it selected. They have course ID in common, course ID in common. Then later on, we'll talk about some concepts very soon. Let's just go ahead and save the relationship. And once we save it, we are going to see that the relationship is established. And we are going to see that it is established. So if you move this around, you are going to see that performance and courses have a relationship. All right, this is fine. We are going to establish another relationship. And the second relationship is between courses and programs. Please pay attention. Dim courses and dim programs. All right. So we have dim programs here, and we have dim courses here, and they are being dim courses, dim programs, and their relationship is being established on this field called program names. So let's come back here, and courses and programs, they are having relationship on program names. So we'll drag program name from here and drop it on program name over here. We'll see this new relationship dialog, and we will see what they have in common from courses to programs. And let me see if that is right from our slides, from courses to programs. All right, so that is important, knowing the from and the to. All right, and you can see what they have in common. We have program names, and then you save the relationship, and that relationship is also established. All right, so now that the two relationships are established and we have this going on, let's go back to our report view, and now tell me what just happened here. The same visuals that we had on page 2, who can tell me what is happening now? What is happening now? Who can tell me? What is happening now? They are working. Thank you, Lucretia. As simple as that. They are showing accurate results. So now you can see that they are not all showing the totals, and they are working now. And they are now talking to each other. They are now communicating, because these are two different tables. Let me go back and just test this. I'm going to delete a relationship. Let me delete a relationship. and see what happened again. Let me go back here, and now they are not right. Okay, see what is happening? After, when I click on this, does it affect this table? Yes or no? I am clicking. Does it affect this table? Is it affecting it? Is it affecting it? No, it's not. They are not communicating. They are not communicating. They are not communicating. They are not communicating. And the reason why they are not communicating is because there is no relationship. So I want you to fix this right now. Establish the relationship we talked about. If you remember them, please establish them and take a screenshot of your page 2 and let me see it. If you want to see the slide again, I can put it up and you'll see the relationship. Francis is already done. Francis is done. Okay, so when you finish setting up the relationship and it's working, please post both your relationship view and your model view and your visual view, your report view. Let me see that too. So I can see Lucretia, beautiful. Ibrahim, beautiful. Nkululeko, beautiful. Thank you. Thank you. Beautiful. Beautiful. Thank you very much. All right. So we can see all of these. That's beautiful. That's beautiful. All right. So let me establish my relationship and then we can continue. So facts and courses on course ID. So let me go back to model view and performance and courses. Fact performance and dim courses. So on course ID, let me set up the relationship again. So instead of telling you about relationships, now you get a feel of how to set up relationship. Now, in future, I'm going to tell you that the relationship between dim courses and dim programs is not really ideal. I'm going to tell you that. For the last time, why is the relationship not ideal? Why is the relationship between dim courses and dim programs? Why is the relationship not ideal? Because the key is test-based. Thank you very much. So that is it. For now, it is working. It is okay. We are going to use it like that, but we are going to correct it. If I make the switch now, then that means I'm changing a lot from my slides. So maybe we should just leave it and we'll do it later on. But please take note of this. We'll do it later in this lesson, but take note of this. All right. So the outcome, now the bar chart and the table visual will show correct data because Power BI can relate the data across the tables. Beautiful, beautiful. So this is what we have exactly, and it is working. This is beautiful. So this is from my slides. And this is what we saw. How relationship works. To build a relationship, Power BI uses a primary key in one table, which has unique values, and a foreign key in another table, which has repeated values. All right. So let me use the opportunity to talk about primary keys and foreign keys. Now, in database management and in working with tables and data, we have what is called unique identifiers. Unique identifiers. Please type that in the chat. Let me quickly talk about that. Unique identifiers. Unique identifiers. Unique identifiers. Thank you very much. Now, this concept of unique identifiers is really important because when data is stored, we want to ensure that there is a field that has values that are always unique. Let me give you an example with Power BI. Let's go to our model view and let's see something. Let's use DIM students for this example. Now, if you are the one creating this table as a data professional or a software engineer building an e-commerce website, nobody will tell you that you need a table called student ID. Nobody will tell you. But you, as a professional, you have to know that to create a student's table or a customer's table or a product table, I have to begin with student ID. You have to know that because you have to intentionally include a field, even if it was not given to you by your client. You have to include it because you want a field that will store unique values to be used as unique identifiers. Because in every table, we have to have something that points to something unique about the table. Okay, let's talk about all the fields in the table. This student's table, it has a first name field. Can we rely on the first name field to store unique values? Can we rely on it? Please tell me, can we rely on it? No. No. Why can't we rely on it? Why can't we rely on it? Even though right now there's only one Benedine at Rita Africa, as a professional, should you design your table relying on first name? Do you have to do that? Right now, there's no other Benedine. But as a professional, you can't rely on first name because maybe another Benedine will show up next month. So if you want to use Benedine to track the Benedine you know, the name, first name field will not work in future. Maybe today is working, but in future it's not going to work because there may be two Benedines and your application is going to fail because it doesn't know which Benedine you are referring to now. Okay, let's move on. Can you rely on gender? Can you rely on gender? Can you rely on gender? No, you can't rely on gender because you can't say male and you get a particular person. You're not going to do that. Maybe last name will work. Can we rely on last name? Can we rely on it? No, someone says no. Okay. So because of that, listen, we are not going to bother ourselves with any other field. We are going to intentionally, listen to me, even if the school gives you student ID numbers, that is fine. But as a data professional, forget about it. You have to intentionally include a field that you have named student ID. Let me highlight it well. Because I want to create a field that will ensure that the values within it programmatically has unique values. I say programmatically because maybe the student ID is used in the context of when the students meet. But as an application developer, you don't think like that. You have to think of the code aspect of your application, and you have to know that you need a field that store only numbers because some of the student IDs may have alphanumeric values or digit characters. So we have to include this student ID. Now, in a database environment, you can program this field to auto-generate the numbers. We call it auto-increment. So if you auto-increment it, you are telling your database system that, listen, This field, I'm reserving it for unique identifiers, and I don't even want to touch it. So anytime there's a new student, generate it for me by looking at the last one and incrementing it and creating the new one. So the values for this, the system can handle it. Of course, in Excel, we don't have that complexity, so you have to enter it yourself. But if you are working in a database, you don't have to touch it. You have to let the system generate it for you. If you touch it, it will still work, but it's not the best. All right. This brings us to the concept of unique identifiers because in the table, we have to intentionally create that field for the purpose of identifying a unique item. So in the database, programmatically, if I see the student ID, not the student ID given by the school, but the student ID in my database table that I have included as my unique identifier, if I see the ID number of a particular student, I can be sure that I can rely on it. Okay, let me ask this question now. Can we rely on this field to find a particular student? Can we rely on it? Yes, we can rely on it because it is intended to store unique identifiers. All right. Now, since we can rely on it and it belongs to this table, it belongs to this table. This is the home table. This is the home table. Please type home table, home table, home table. Type home table. Because it belongs to this table, it is called a primary key. It's called a primary key. Please type primary key for me. Because this is its home table. This is its home table. Okay, fine. Now let's look at something else. This student ID field we have created, let's move to a different table. Let's move to a different table now. And let's start talking about, let's say performance here. Okay, this performance is storing data about performance. If you are the database designer or the table designer, what is the first field you will create when you are creating a table called performance? What is the first field you will create? Regardless of any other field that will come later. What is the first field you will create? Okay, if it were me as a professional, I will create a field called performance ID because this is the home table. And so this performance ID is called, this performance ID is called what? A primary key because this is the home table. Now watch this. This same time, I can see a table a field that I know already, but wait a minute. This field doesn't belong to this table. So what is it doing here? I'm just trying to highlight it for you. This field doesn't belong to this table. So what is it doing here? Okay. Now, this is a field I'm talking about. Do you recognize this field? The same field, do you recognize it? All right. But this field doesn't belong to this table. This is not the home table of this particular field. Where does this field come from? Where does it come from? Where does it come from? Where does it come from? Okay, I'm talking to those watching the video. For you, I know you know it already, but I'm talking to the beginner watching this video. It comes from the students table. Okay, before I ask you what it is doing here, I'm going to tell you something. In its home table, it is called a primary key, but it has found itself in someone else's table, and it is also an ID. Right now, it is no longer called a primary key. Who can tell me what it is called? The same thing that was a primary key yesterday, today it is called what? A foreign key. This is all about the concept of primary key and foreign key. If a key is added to a different table, but it is the primary key of its home table, but now it finds itself in a different table, now it is called a foreign key. Okay, now to the big question. Why did we include student ID in performance table? Why did we do that? Who can tell me why? Why did we include? I'm trying to get this understanding. Why did we include? Because the person creating this table is intelligent enough to know that later he will build a relationship with students. And he knows that if he repeats student name in this table, it is wrong because this is a fact table, number one. Number two, if you repeat student name here, it is called redundant data. Please type redundant data. Redundant data. You know the problem of redundant data? It is storing too much unnecessary information in different tables. We don't need it. Okay, what if we edit it somewhere else? Now it is at two places. Number one, it is going to make your file size heavier. It's going to waste storage space. It is going to make your system slow. It's going to make your system slow. And number two, it's going to create duplication in your database. So we don't need redundant data. So the person designing this table is very intelligent and knows that all I need is the ID. I don't need any other information because after all, if I use the name is the name enough for me to know all about the student? Is the name alone? Let's say I bring the name. Is it enough for me to know all about the student? Okay, there's a lot of information about the student. So if I think I want to know more about the student, then I will end up bringing every student information into this table. Then you realize that the redundancy is becoming worse. Okay, so we decide that, listen, we don't want any student information. All we want is an ID. And this is called a foreign key. That's all. As a foreign key, we can use it tomorrow to create a relationship. And when that relationship is established, guess what will happen? We will be able to retrieve every other student information we want. So look at this database administrator here. You can see the table he's creating and he's typing order ID, product ID. Look at this one. Order ID, customer ID, payment ID. This means he's very intelligent. He's very intelligent. So when you see all these IDs being added, they are being added for a purpose. Look at product ID, category ID, inventory ID. Because, oh, you can even see this. You can see that this ID from product has a link all the way to categories, you see? So instead of dumping the category information into the products, it is wrong. So when you are designing a database, instead of entering unrelated data in the same table, we don't do that. You have to create a different entity about a table that has one type of information. And then you just link them through your IDs. All right, so last question. Last question. This other ID, is it a primary key or foreign key? Let me see in the charts. Okay, okay. I'm checking if someone will make a mistake, but I've seen from a lot of people and everyone is right. All right, now watch this. This payment ID, is it a primary key or foreign key? Let me see. After this, I'm satisfied. Is this a primary key or foreign key? And everybody got it right as well. So case closed. Now I know I've explained it well. All right. So in Power BI, to build a relationship, Power BI uses primary keys and foreign keys to establish the relationships. Power BI links them so that you can use info from one table to analyze another table or while analyzing another table. So let's say you are analyzing performance table, you can see the student information, which students you are talking about. Meanwhile, in the performance table, all you had was student ID. And this ID as a foreign key is able to connect to the student's table's primary key and the relationship is established. All right. Now to continue, we are going to talk about relationship control filtering. All right, sorry. All right, so this is just a statement, okay? This is just a statement, and I'll tell you something very important very soon. Now, the statement is that relationships control filtering in Power BI. This statement is telling you that if the relationship is not established, this filtering is not going to work when you are dealing with multiple data. So this is called filtering, and it is done through relationships. Now, in page one, the filtering worked because it was just one table. But in page two, the filtering will not work. And in your report, the filtering will not work. So relationship controls the filtering. Tables can filter one another because of relationships. This point is very clear. Now let's talk about types of relationships. Types of relationships. All right. Now, Power BI supports four main types of relationships. Three of them are common and one is rare. The most common one and the most recommended one is called one-to-many. This is the most used and most recommended. But there are different types of relationships in Power BI. This is called one-to-many. Please type that in the chat for me. One-to-many. I'll wrap up soon and we'll continue in the next class. Now, one-to-many, one row in table A matches many rows in table B. This is very common. This is the most common one. All right, so we are talking about relationships here. Let's take our time and understand it practically, one-to-many relationships. All right, so in Power BI, if you go back to the model view and you establish the relationship, now you are going to see that in the courses here, between courses and performance, the relationship is one here, but here it is star, meaning many. So the type of relationship between these two tables is called one-to-many. You can see the arrow here, one-to-many. All right. Over here, this is also one-to-many. Okay, let's explain what this means. Okay, let's use programs table and let's use courses table. And why are we saying one-to-many? Let's think about it for a minute. Let me bring this here. Now, the relationship between these two is one-to-many because in this table, if you find a program, it exists only once. For example, data analytics exists only once in this table. But if you come to courses, you are going to see Python programming as a course. And the program name for Python programming is data analytics. Okay. Then you are going to see data visualization with Power BI, a different course, but the name of the program is also data analytics. Okay. You are going to see data analytics with Excel as a course. You are going to see Tableau as a course, but the program is data analytics again. This means data analytics is found only once over here, but can be found many times in this table. So one program can have many courses. Beautiful. So data analytics in this table has many courses in this table. Or the entries, the records. Here, let's talk about the record, the entries. You find multiple entries of data analytics in this table, or multiple entries of the same program in this table. This is why the relationship is one under program name. You can see the relationship is program name, and it relates to many under program name as well. All right, so this is clear. We also have many to one, same as the above, just viewed from the other side. So it's the same, but when you view it from the other side, it's many to one. Then we have many to many. Both sides contain duplicates. Avoid this. Avoid it unless it's necessary. So avoid many to many relationships because it can create a lot of confusion, a lot of duplication. Then we have one to one. This is rare. But both tables have only one matching row per value. So sometimes you can see one to one, but it is rare. So these are the four types of relationship. And after I talk about the next point, I'm going to end the class here and we will continue tomorrow. Okay. The next point here is called cardinality of the relationship. Cardinality. Please type cardinality in the charts. Cardinality. Cardinality. Thank you very much. Thank you very much. All right. Now, this concept of one to many, many to one, many to many, one to one, this same concept is also referred to as the cardinality of the relationships. This same thing. So when you are asked, what is the cardinality? We are going to say one to many to one, many to many, and one to one. And they have these symbols. So one to many has these symbols, and I've already showed you in Power BI. Many to one has this, many to many has this, and one to one has this. Let me show it to you again in Power BI. So let's use the same tables we use. So these cardinality symbols, what does it refer to? What does it mean? The symbols you are seeing now, what does it mean? What does it mean? What does it mean? Okay. So it shows you the relationship. So you can see right from here. Thank you very much. And it has a direction of relationship. So there's something called direction of relationship, which I'm going to show you briefly under the same cardinality. Relationship also have what is called a filter direction. Please type filter direction in the chat for me. Filter direction. Filter direction. All right. Which controls how filters flow. So this is important. This is important. Please take note of it. We are ending the class, but take note of this important information. The flow of the filtering, the flow of the filtering, the direction of the relationship. Now, watch this. We have single direction. This means that filters flow from one table to another table. Then we have both directions, which means filters flow both ways. Now use this flow carefully because they may slow the performance of your reports. In Power BI defaults to single direction, going from dim to fact. And the last point here, let me explain this to you practically, and we are done. So I want you to double click on the relationship line. Double click on the relationship line and tell me if this dialog box is familiar. Double click on it and tell me if it is familiar. Is it familiar? Okay, good. Now, let's zoom into this area and tell me what you see here. I don't know if you can see my screen. What do you see here? What do you see here? Okay. All right. And if you can see, this means that you can see all the cardinalities here. And this is many to one or one to many, depending on where you read it from. So this is where you can change the cardinality if you want and if it's possible. And at the same time, please tell me what you see here at the right side. This is the last thing I'm saying and we'll close. What do you see here? What do you see here? The title. Tell me the title. The heading. All right. So this is called cross filter direction, and you can see single and both. So this talks about filtering and the direction of the filtering. Power BI result defaults to single, and you can also use both when during filtering. We'll talk about this again in our next class, but this is where we end today's lesson. Let me know in the chat if you have learned something new today. Did you learn anything new? Did you enjoy the class? Okay, so Francis says, yes, I learned something new. Lovely says a lot. Timothy says, learned a lot. And thank you very much. This has been a wonderful class, and this is where we end the class. We will continue from here, and we will build an amazing report that will blow your mind and catapult you into an advanced Power BI user. So thank you very much. Have a wonderful evening, and I'll see you in the next class. I wish you all the best. Bye-bye.